straight into it, and we're going to take a couple of simple examples and see if we can expand it out. Now, you'll forgive me, I'm using a new technology today. I'm just using a digital pen because of the difficulties that we have with Word document doing superscript and stuff. It'll just be a little bit slower. So I'm going to take a simple example, and we're going to convert it into its decimal counterpart. So the number we're going to choose is, we'll just start off with a nice simple one. So we have 1, we'll go down a little bit lower there because I want to expand it out above it. Okay. So we have 1, 0, 0, 1, 0, and that's to the base 2. Now, in order to get its decimal counterpart, what we do is expand. We have its position because we get 2 to the 0. We have 2 to the 1, 2 to the power of 2, and 2 to the power of 3, and we have 2 to the power of 4. Now, we're not concerned with any of the zeros because, as we all know, anything multiplied by 0 will give you nothing. It will give you 0. So we'll only concentrate on the 1s. So in this case, it'll be 1 multiplied by 2 to the power of 4, which just put it in here, 2 to the power of 4, plus 1 multiplied by 2 to the power of 1. And we know 2 2s is 4, and 2 4s is 8, and 2 8s is 16, so that'd be 16. So what we can do is it's equal to 16 plus, and we know 2 1s is just the 2, so that equals to 2, which is equal to 18. So that's its decimal format, and that's base 10, just to clarify things. Now what we'll do is we will actually choose another one with maybe a decimal at the side of it, just to kind of clear it up. Maybe we'll go a little bit longer. So what I'll do is I'll just clear that one. Okay, and what we'll do is we'll go with one a little bit more complicated. So we'll go with 1, 0, 1, 1, 0, 1, 1, 1, 0.101. Now, and again, that's to the base 2. So the same rules apply. We have to expand it out to get its digital counterpart, decimal counterpart, I should say. So we'll start here with 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. Now, what we do is we come to this side, and it's actually 2 to the power of minus 1, 2 to the power of minus 2, and the other one is 2 to the power of minus 3. Now, so again, we ignore any of the zeros, and we'll write it down, and we add the numbers. So it'll be 1 multiplied by 2 to the power of 7 plus, now we're skipping any of the zeros, because anything multiplied by 0 will give us 0, plus 1 multiplied by 2 to the power of 5 plus 1 multiplied by 2 to the power of 4 plus, again we're skipping the 0 because it has no bearing on it, plus 1 multiplied by 2 to the power of 2 plus 1 multiplied by 2 to the power of 1 plus 1 multiplied by 2 to the power of 0. Now this would give us our number before the decimal place. But we can continue on because what we can do is put this all into the computer or into the calculator. So plus 1 multiplied by 2 to the power of minus 1 plus, and our last one then is 1 multiplied by 2 to the power of minus 3. Now, when you calculate all of that and put it into the calculator as is, and that's the easiest way, you can expand 2 to the power of 7 out, and you'll end up with 128. So it would look something like 128 plus 2 to the power of 5, which would be 32, and then 2 to the power of 4, which would be 16, and just add those up in the numbers. But when you're dealing with numbers this big, you're nearly better off just put it all into the calculator and press the equal sign. So as you see it, put it into the calculator. And when you do that, you'll come up with an answer of 183.625. Because wherever there's a decimal place in your binary, you'll still have a decimal place into your decimal number, and that's base 10. Okay, so try that and see how we get on with that. And we might do another one just here. So we'll just have a look at one more. We'll just clear that. There we go. And we'll do a simple one here again. So 1, 0, 1, 1, 0, 1. That's base 2. Again, we start here, so it's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the power of 3, 2 to the power of 4, and 2 to the power of 5. Again, we're not only concerned with the 1. So if we come to the 1, and we can just go, it's 1 multiplied by, and remember I said you could expand out 2 to the power of 5 if you wanted to. So that's 1 multiplied by 32, plus nothing for the 0, because 0 by anything will still be 0. And 1 by 2 to the power of 3, which would be 8. So we can go 1 multiplied by 8, plus 1 multiplied by 2 to the power of 2, which is 4. So multiplied by 4. Again, we skip the 0, because there's no value on it. Plus, and our last one is 1 multiplied by 2 to the power of 0, which we know is 1. So, multiply 2 to the power of 0. So, we can get rid of that. We stick with the format we had. And I'll just put in 1 here rather than what we're looking at there. Same. So, multiplied by 1. And that should give us 45 if I add that up right. 32 plus 8 is 40, plus 4 is 44, plus 1 is 45. So our decimal number would be 45. Now you could have done that in exactly the same way, where you put it into your calculator by 1 multiplied by 2 to the power of 5, plus 1 multiplied by 2 to the power of 3, plus 1 multiplied by 2 to the power of 2, plus 1 multiplied by 2 to the power of 0. It would still give you 45. But it's whichever way you're kind of comfortable with. Some people like doing it both ways. So that's it for the expanding of a binary number to its decimal counterpart. There'll be more videos following on, and I'll see you in the next video where I think we're moving on to octal. See you soon. Bye-bye.